Okay, welcome students to Forensics 1. This is your first instructional video. So what we're going to do now is we're going to start off with our notes. If you were in class, you received your book. You're going to start right off with topic 1, which is called Intro. I'm going to break it up into different parts and go through it a little bit at a time. And then we'll do some activities out of your workbook and other activities that I can come up with. So we're going to learn about forensic science. In forensic science, we say that it is debatable. Okay, that is an area of science where you are going to have a bunch of evidence that's collected by a scientific method, and then you're going to put together an argument about who is the suspect, and you have to link your suspect to your victim, to the crime scene, to the motive. And that's what we mean by it's a debatable thing, because you will have two sides of the debate. Yes, the person's the best suspect and actually did the crime. No, the person didn't. Okay, so it really is the application of science to criminal and civil laws that are enforced by policies, agencies, police agencies in a criminal justice system. So, again, there will be sides. People will debate. Was the evidence collected correctly? Procedure followed? Does it really support what's going on? What the hypothesis is? Have they proven their point? So we're going to do a little bit of historical background on forensics. We're going to talk about very influential people. So when you take a forensics test, whether it's going to be an online test or it's going to be an in-person test, you are allowed a study card. Now, if it's an online test, I usually tell you it's open note, but when it's an in-person test, you will be given a 3x5 card. You can write on both sides of the card and use that card when you take the test. The people are things that I would put on the card because it's hard to remember who did what. We are going to meet some of these, and I'll put meet in quotations, because we're going to learn about some of these on different topics as we go along on the course of the year. And one is Matthew Orfila. Matthew Orfila was what we call the forensics of father of forensics toxicology. He is originally Spanish. He did a lot of his work in France. He taught medicine in France. So he studied a lot about the human body, illnesses, toxicology, poisoning. He was one who really looked at poisoning. He did it at the time where, people had a lot of arranged marriages and they didn't particularly care for their spouses. So they would, slip them a little something in their food. And then, lo and behold, the spouse died. And he was very good at figuring out, well, how did that spouse die? And he started this whole thing of toxicology. Now, forensics toxicology, we do not discuss in Forensics 1. That toxicology is discussed in Forensic 2, and if you take Forensics 2, we spend an awful lot of time on toxicology. Alphonse Bertillon, another French person, he was somebody who spent time looking at what was called biometrics or anthropometry. In other words, measurement of the body, measurement of the skeletal system. He had, I think it was 11 total measurements where he could measure, for instance, from the base of your hand to the tip of your middle finger, the width of your palm, the length of your femur, looking at your skull. And he had all these biometrics that would be able to categorize, hey, was the skeleton we found female or male? How old was it? That kind of thing. That was the main way people were identified, and then that was replaced in the mid-1900s with fingerprinting. Okay, now Francis Galton is a pioneer of looking at fingerprints. He has a whole book on identifying them, the types of fingerprints. Fingerprints are something that we do spend a time on in Forensics 1. More of the anthropometry anthropometry is done in forensics too if we have time to do it. Usually we run out of time. But Francis Galton did a lot of work on proving that a fingerprint could identify a person, an assailant. So he wrote a book about it, and it was held up in the courts in the 1990s that you could use a fingerprint as a piece of evidence. There are people in the United States now that maintain there's not enough scientific research to truly prove that everybody's fingerprint is unique because they haven't done it in a methodical way. And so there's a big debate now, mostly out of Texas, about how there isn't enough statistical analysis to prove how the FBI matches fingerprints or how a police station matches fingerprints using an electronic device, how that's really accurate. You have to understand, in other countries, there is a higher degree of what's called identification marks. In some countries, you need 24 coincidental marks. In the United States, we only use 8. And I think that's really where their argument stems. Okay. Now, guys, in your notebook, I think there's an error. So I think there's 2 pages that are exactly the same, or people are repeated. You only have to fill in the person once, because there's not going to be any different information. And I think Leon here is one of the ones that's in there twice. Okay, he's the one who did blood typing. So there's a lot that people talk about right now about blood typing because they say that certain types of blood are more susceptible to COVID infection, that blood O is most resistant, or least amount of people infected percentage-wise have O type. There's a higher percentage of A type that get infected. So he developed blood typing. Usually you do blood typing in living environment. You do a little lab about it. We will discuss a little bit about blood typing. We'll do a little activity on blood typing to refresh your memory from living environment. For those of you who haven't taken living environment, you'll have a little precursor to what you'll do on blood type groups. He was instrumental of being able to take dried blood at a crime scene and figure out what the blood group was from it, and that was a big deal. Okay, Calvin Goddard worked for, or was, a U.S. Army colonel, and he developed a lot of the methodology between matching firearms with their ballistics. So he really founded the ballistics category. We don't do anything with ballistics because the activities are kind of cheesy that you can buy when you can't go to a ballistic lab and use a tank and fire a gun, and we can't have gun on the premise. So we don't do anything with ballistics. Ooh, why did it do that? Okay. The next one is Albert Osborne, and he did a whole study on documentation and whether or not people forge documents, counterfeiting, mainly forgery for him because it was a big thing about, wills and money and signing checks and that kind of thing. So he developed most of the principles that are used even now, currently, in court systems about looking and examining documents. We do a unit on documentation, so we look at forgery, we look at counterfeiting, we look at handwriting, we look at inks. We don't spend a lot of time on different papers, but we do have a little activity to look at papers if we're allowed to do labs. Okay. Henry Gross, he was one of the people that spent a long time looking at how trials were conducted. He was a judge, so he was in the system, and he looked at how evidence was brought into the court and used. And so he came up with trying to approach evidence more from a scientific end, not circumstantial. Right? So a lot of times he found people were prosecuted on circumstantial evidence. People were prosecuted on eyewitness evidence. And he was, and in his age, especially back in Australia, where people were fighting for land, and there could be feuds going on, there could be a huge land war, a huge feud between two people who want to take over each other's land or have right to water or anything like that. And if one person's powerful enough, they could bribe others and say, oh yeah, Joey down the road was the one who shot this other guy and killed him when Joey had nothing to do with it. And as long as they could coerce enough people to testify, somebody could get essentially the term railroaded into a conviction. So he started thinking you got to have more substantial evidence than just eyewitness evidence. So he really was, in a way, a pioneer of the topic of forensic science. You know, let's go and look for true evidence. Something that's left behind, something that really ties the person together. Not just a band of people, you know, waving a pitchfork and saying, no, he's the one who did it. Now, Locard, this kind of brings us to Locard, because he built on Henry Gross's background. And Locard put together this idea, this philosophy. And this is an important philosophy. He developed what is commonly referred to as Locard's principle. Okay, so in your book, on your notes, as you're taking stuff down, you have to make sure that you highlight this box. This is the important principle of forensic science. And what he said, and this is in your book already, so highlight it. A lot of people skip over it because I don't make you write this. With every contact people have, they leave something behind. Okay, now this is actually quite prevalent for today, because we talk about the spread of the virus and its aerosol little particles. We can't see them. Well, that's the whole point of forensics. We can't see the traces of our existence that we leave behind. I touch and brush against a bench. Well, my fibers, my skin oil, my skin cells can be left on that bench. I walk down the hallway. Well, we may not be able to see it, but there's wax on the floor, and in actuality, I leave little footprints in the wax, depending on what wax they buy for the district, how hard they make the wax when they spread it on the floor. On days in the classroom, when the sun is hitting the floor correctly, if someone has just the right type of dust and they walk on that floor, you can see their footprints on top of the wax. So everything we do leaves a trace behind. And I've had students say, well, you know, if you go commit a crime, what if you take your shoes off and you walk around in your bare feet, or you walk around in your socks? Well, if you walk around in your socks have fibers. Fibers are going to be left in the crime scene. And those fibers, because manufacturers now document a lot about their fibers, can be cataloged and searched. So they can find out who manufactures that fiber and what they use it for. And sooner or later, it'll come back to the person who committed the crime. Some people said, well, I'll just put booties on my feet. Well, you have to buy the booties, and the booties are made out of paper and fiber, so guess what they leave behind? Alright, now, we're going to go through some vocabulary. You need to know all of it. You need to copy it down. You need to process it. There's some worksheets I'm going to have you read and fill out that help you process the vocabulary. Crime scene. Crime scene is any physical location in which a crime has occurred or you think has occurred. And I'll come back to that. I always use my poor niece as an excuse. Okay, we have what's called a primary crime scene. So that is actually where the real crime occurred. Okay, so a burglary. That's where somebody broke into a house. It's the house that was broken into. A murder. It's the actual place that the murder was committed. What else? Shoplifting. It's the actual store from which you shoplifted. Okay, that's the primary crime scene. We can have what's called a secondary crime scene. The guy robs a store. Meets up with his buddy at his buddy's house. Buddy has no idea his friend just robbed a store. He goes, yo, I'm moving and I just got this TV and it's nice TV, but I don't have any place to store it because I'm moving. Could you just put it in your basement? If your basement's dry, you know, put it in your basement. I'll come pick it up later. And, you know, he hasn't seen his buddy in a while. Yeah, put it in the basement. Well, it's a stolen television. Right? Police come and say, hey, did you take a television from somebody, you're storing it? And, person's honest, doesn't know anything that's going on. Yep, it's downstairs. Well, his basement now becomes a secondary crime scene because the article that was stolen is now placed in his basement, and that's now an area that holds this stolen article. Okay? Somebody moves a dead body, puts it in the trunk of the car. It's a secondary crime scene. Okay. I think you've heard the term suspect. It is the person who is suspected of being capable of having the motive, etc., of committing the crime. The suspect can have what's called an accomplice, someone that helped them create the crime, do the crime. The accomplice could be somebody who actually puts the plan in place but doesn't execute the crime. An accomplice could also be an unwitting accomplice. For example, the guy who said, "Yeah, store the TV in my house." He had no idea it was stolen, but he technically is an accomplice because he is harboring stolen material. And so they could arrest him for possession of stolen goods. He could be prosecuted for that. Usually somebody's like, "I'm not going down for my buddy. He just showed up. This is my buddy. This is his address. You can go get him." If he knows where he lives. Okay, an alibi is a statement of where the suspect was at the time of the crime. It gives them a location and says there's no way that person could have committed the crime. You work a shift that you have to punch a time clock. So you punch in, the crime is committed while you're on the clock working, and you're there. Cameras of the factory show you're there. Or let's say you're a driver and you make a delivery, and at the time of delivery, the crime was committed, but you were at somebody else's delivering something. There's no way you could have committed the crime. It doesn't mean you weren't involved in it, but you couldn't have committed the crime. Okay. We're going to go through, and I'm going to see if I can figure out how to do this for you. But there's a little thing that I have people do. I might be able to do this. I usually give you puzzle pieces, and I tell you, here's this puzzle piece, and you've got to be able to put the puzzle pieces back in and together and make a square out of them. So I might do it on Google Slides for you. It makes you go through this scientific method, and you know the scientific method. It's been probably drowned into your head, like pounded into your head over and over again since you were in elementary school. Right? So in scientific method, you look at the system and you state the problem. Okay? You form a hypothesis for it. You collect data. And that data collection means that you observe and you experiment. Then you interpret the data. And then if the data supports a hypothesis, you collect more data. You draw conclusions. And then you might repeat the cycle until you have all the evidence that really, in forensic science, points to a person, can support your argument that that person really did the job. They're the one who did it. So when you look at the criminal investigation, the stating the problem is what crime is committed. Okay? When you form a hypothesis, your hypothesis is really based on information that a police officer or an investigating officer, like a detective, will collect at the scene of the crime. It could be the collection of the physical evidence that goes out and gets analyzed and the reports that come back from that. It can be witnesses that say, "Oh, I saw so-and-so do it." They use that to start as a starting point, but cases are not just based only on witnesses anymore. It can be finding evidence that says, "Oh yeah, the person really had a motive," or finding evidence that puts a person at the crime scene. Okay. When you collect data, and this goes under collecting data, you have to really seek out pertinent records. You have to look at anything that's there, any piece of paper that's left, any phone record, any banking record, any communication, depending on the crime. So you really have to evaluate everything that's there. Once you collect all that data and it's out for analysis in labs and you get the results back, you have to go back to that and say, does it all fit? And if it doesn't, you either have to go find the evidence that supports it, or you have to look for another suspect. So this, like I said, it's kind of like a circular type of process. You know, usually the problem doesn't change. You know, it's a particular crime, but collecting the evidence, analyzing, going back, reanalyzing, going to see if there's more evidence, just so that you have everything that you need to go through this. So review and evaluate, that's like interpreting the data. When you seek additional advice that helps you support your case, again, that's more collecting more data. That's like number 5. And once you get all the way done, you can arrest a suspect, and that's drawing the conclusions. So the scientific method is a huge thing that's used. You just don't realize that that's the process you're going through when you do forensics. Okay, whether you're doing it in my classroom, or whether you're doing it at home, or you're watching a murder mystery and you're trying to figure out who did it, it's a process you go through by looking at all the evidence that you have. Okay. So, often it is what questions you ask and then the answers to those questions that lead you in the right direction. If you're asking a question that's not pertinent, you might think it is, but it really isn't. It may not lead you in the right direction. So you got to be always, when we're doing this, and I'm going to try to have you do the scientific method, because you always think you got it. I got the answer. And then sometimes a curveball is thrown and something doesn't fit. And then you have to go back and reformulate. So that scientific method that I'm going to ask you to process through, whether you're at home, I'm going to give you some little shapes on Google Slides, whether you're in the classroom, and you're going to work with shapes that I give you. It's stuff that you have to go through. It's things that you have to think about. And there's something else. When you're in this classroom, no one is an expert. I don't care how many forensic files you've watched. I don't care how many Criminal Minds episodes. It doesn't matter. Everyone brings an analytical aspect to the table that's different from somebody else. And somebody that you're discussing with, and most of our discussions are going to have to be, through the computer, because we can't sit next to each other and handle the same evidence back and forth. So we might look at similar evidence on the computer or something I project, but you have to listen to what people around you are saying. You can voice your opinion. You ask for their opinion, and don't be shy, people. If you're sitting there going, I just want to sit here and give my credit, you have to participate, because forensics is about making observations. We're not going to look at each other and say, well, I think that's a silly observation. Every observation counts. And that bottom line there about the answer is always there, it's just a matter of asking the right questions. You might make an observation one day that is not pertinent to what you're trying to solve or what you're trying to determine. It doesn't mean your observation is awful. It just means that what you made didn't count for the day. Could count on another day. But for that one question that we're trying to solve, you might have been a little bit off. Or your partner might have been a little off. You don't ridicule, you don't put people down. You discuss the evidence and you come to a common consensus. This is not a class to be in if you're going to just sit there and sit on your butt and do nothing, or you're going to be highly critical of others, because we have to work as a team. Okay, so I'm going to stop there. We're going to do little activities about scientific method, but that is your first instruction.